Today you join me on Skuleberget in Sweden because this mountain holds quite an interesting claim to fame. This sign says that this is the world's highest coastline at 286 meters above sea level. And when I first heard that, I thought, well, how can that be true? 286 meters isn't even that high, and really, we're not even that close to the sea. Behind me here you can see the sea. It's a very scenic coastline with all these little islands poking out into the Baltic Sea. 20,000 years ago this area was covered in kilometres of ice, making up the Fennoscandian ice sheet. That ice stuck around until around 10,000 years ago when this land finally became exposed. Now that huge melting of ice introduced a huge amount of water to the sea and caused a massive sea level rise, which among other things cut off the UK from mainland Europe. And since then, the sea level has continued to rise as the ice in the final remaining ice caps continues to melt. And even though that water's been rising ever since the ice started melting, the water has never actually been as far down from where I'm stood right now as it is today. Once upon a time, the land where I'm stood right now was actually an island, just poking up above the surface of the water. So how can that be? Well, it's all down to a process called isostatic rebound. As I stand here, I'm applying a pressure to the ground, and that is likely causing the ground to compress a bit under where I'm stood. But it's not particularly noticeable unless I'm stood on very soft, spongy ground, because on a geological scale, I'm not actually very heavy. But if I were a several kilometre thick ice sheet, well, that would be a different story, and I would actually compress the ground by quite a bit. The land right here is still recovering from that compression because it's only been a few thousand years. Although it doesn't feel like it, the land beneath my feet is actually rising by a few millimetres every year. A few thousand years ago, the mountain where I'm stood right now would have been a coastline. It would have just been an island sticking up in the sea. And this piece of metal here is put down to represent where that coastline would have been. So where I stand now, the water would have lapped at my feet. But now I'm 286 meters above sea level because of how fast this mountain is rising out of the sea. This is in fact the highest known point on the entire planet to have been lifted by glacial isostatic rebound. Pretty much everything that you can see from the top of Skuleberget was recently completely underwater. Down here by the present day water's edge, this land has only recently been exposed in the last sort of 100 years or so. This area is known as the Höga Kusten, the high coast, and it's actually been designated a UNESCO World Heritage Site because of the impressive isostatic rebound that's going on here. Just over the horizon over there is Finland, and Finland is also experiencing the same effect that we're having here. But because the land is so flat over there, it's much more noticeable, and they're actually seeing large portions of land being gained every single year. This area has one of the highest rates of isostatic rebound in the world, and in fact some scientists believe that in just a few thousand years the sea behind me here will be split in two by the land rising up and forming a land bridge between Sweden and Finland in an area called Norra Kvarken, just a bit further north than here. So is this nature's answer to climate change induced sea level rise? Well, not exactly. While this part of the world may be rising, other parts of the world are sinking. Places like the UK, for example, are actually tilting. Scotland is getting higher while the south of England sinks and gets lower. So in a lot of places, this effect is actually worsening the sea level rise caused by climate change. Here, however, the sea's got quite a bit of catching up to do if it wants to catch up with this land as it rapidly rises out of the water. So yes, I suppose this really is the world's highest coastline.